So we just take the value, number of successes, subtract the mean, and square that, and then multiply by the probability. So let's see, standard deviation equals number of successes so 0 minus the mean is 1.5, square that, and then multiply by the probability. Okay, and then we add that to the next number of successes, squared, number of successes minus the mean squared plus times the probability of success. Alright, and this is going to get really messy, so instead of doing that, I'm going to go 0 minus 1.5, because that's the mean, squared, times the probability. I had a parenthesis for some reason. Okay, and then drag this down, and then just sum that. Just add all those together. And we got 1.5. Or sorry, yeah. We got 1.5 for sigma squared, so we need to take the square root. Take the square root of 1.5, and we get the 1.0247, which is what we got up here with our standard deviation formula. Alright, so that was that question. Next. American Society of Investors survey found 30% of individual investors have used a discount broker. In a random sample of 9 individuals, what is the probability? So the percentage of success here, 30%, 0.3, and the sample is 9. So let's fill that in. Okay. And then we've already got the exact probabilities. We've already got the cumulative probabilities. What's the probability that exactly 2 sample individuals have used a discount broker? Well, we go to 2, 0.2668. So rounded to 3 decimal places, 0.267. 0.267, good. How about exactly 4? 0.1715, so 0.172. 0.172. Alright, so this is easy, right? The last one, how about none have used it? 0.040. 0.040, okay. So that wasn't too bad. Just need to read it, read off of our chart. Recent study, 90% of homes, that's the probability, 90% have a large screen TV. Whatever large screen means. I know I don't have a large screen TV. So in 9 homes, what's the probability that All 9 have large screen TVs. Okay, so let's go to our chart. 9 homes. 9 is already there. Probability of success was 90%, which is the same as 0.9. Alright, now you got these weird numbers here. 1e negative 0.09. What does that mean? Well, this is scientific notation. It means that the probability is 1 times 10 to the negative 9th, which means we have 0.8 zeros and then a 1. So very small probability. I think if I move this over, no, it still doesn't show it. So a lot of zeros here. A lot of zeros here. So basically no probability that we have 0 or 1 successes. I mean, there's a little probability, but not much. Okay, so then we start getting into, there's some probability here. Still almost 0 probability. So this is less than 1/1000th of the time we survey 9 homes. There's going to be only 4. All right. So finally we start getting into some real numbers here. Notice, interestingly, 8 and 9 have the same probability, and that just has to do with the way we come up with this combination formula for 8 and 9, and the way the probabilities work out. Okay. So the question: all 9 have large screen TVs. We see the probability is 0.387. 0.387, good. How about less than 5 have large screen TVs? Less than 5. So 5 is 0.07. So that should be the answer, right? 0.007. Well, that's not right. Oh, it's less than 5, right? Less than 5. So what does that mean? Well, it means 4 or 3 or 2 or 1 or 0, right? Less than 5. So if we go over here to the cumulative, that's going to tell us the probabilities of 4 plus probability of us getting 3 large screen TVs in the 9 plus 2 large screen TVs in 9, 1 and 0. So go over to the cumulative probability. Less than 5 means we're going to 4, and we see that it's 0.00089, which rounds to 0.001. Okay, 0.001. So if it says less than, or if it says less than or equal to, or more than or equal to, you're going to want to use your cumulative probabilities. All right, let's see if they ask us some more like that. More than 5 have large screen TVs. More than 5 means 6, 7, 8, or 9. Okay, now how do we figure this one out? Well, we know that the total probability is going to be 1, right, of having 0 successes, 1, 2, 3, 4, 5, 6, 7, 8, or 9 successes. The total probability is 1 if we add them all up. Now, they're asking for what about more than 5, so 6, 7, 8, or 9. Well, we can use cumulative probability here. We could just add this, so we could add this number, so equals the sum of 6, 7, 8, and 9, right? Now this is pretty easy to do, but if you're using paper and pencil, it's a little harder to add all these numbers up, right? All right, so we got 0.9917. Now the quicker way, barely quicker on Excel, but a lot quicker if you have the cumulative probabilities right there. The quicker way would be to subtract from 1, because remember 1 is the total. Subtract from 1 the probability, the cumulative probability that you have 5 or less, okay, because we're looking for more than 5. So if we take away the probability that there's 5, 4, 3, 2, 0, 1, or 0, which is this number, then we'll get the same answer, okay? So we could add 6 plus 7 plus 8 plus 9, or we could take 1 and subtract 5 plus 4 plus 3 plus 2 plus 1 plus 0. Which is the same thing as 1 minus the cumulative of 5. Okay? Now, what might make it more clear later on when we use a normal distribution, we could think of, remember that histogram we made? We could think of this being kind of like that histogram, all right? And what we're doing is, instead of the cumulative probability would be telling us the area to the left of a certain point. Oops. The area to the left of a certain point. What we want to do is take 1 and subtract that to find the area greater than a certain point. And we'll get back to that later on. Okay, so more than 5, we take 1 minus the cumulative of 5. At least 7, so that means 7, 8, or 9, right? So again, we could make this 7, 8, or 9, make this F23, and we get 0.947. Or we could come over here and do 1 minus the cumulative probability of 6, so G22. And we'll get the same answer. All right, so we can add them all up, or we can do 1 minus what we don't have. Right, 1 minus what we don't have. It would be like trying to figure out, you know, if you're thinking of baseball and a guy's hitting 300, and you're asked, okay, well, what percentage of the time does he not get a hit? Right? What percentage of the time does he not get a hit? And let's say there's no walks or anything. You could count them all up and get 70% that way, or you could just do 1 minus the 300 and you get 70% that way as well. Okay. So let's go on to